Okay. Good morning. All right, I'm going to get started. Today's lesson is kind of a strange way of thinking. And that's why it gets complicated for people, because you're probably just not used to thinking math this way. This is actually a very creative solution on how to solve these. And it's remarkable in the way that it's going to work every time. So this does work every time. It doesn't matter what your um, quadratic is, you will get your answers every time here. Unlike graphing it, right? If you graph it, you won't get your imaginary numbers, so to speak, or even if it's ugly numbers, it'll be tough to graph. Factoring, not everything is factorable, so you can't always get it that way. When you solve with square roots, you don't always get numbers that are conducive of having square roots to solve. I mean, sometimes you have that b term, so you can't do it. Completing the square, which is a very strange name, we'll get to why it's called that in a minute here, will actually work every single time. So this is a tried and true method that goes to it, and it's actually probably one of my more fun methods to do these to me. You might not think that, because you might not have the appreciation of it that I do, but I think this is a pretty ingenious way that people came up with to solve quadratics. And I'm going to start by explaining the rationale behind it and why it works. And then we'll get into actually doing some practice and using that rationale to solve things. The biggest thing on your note page is that last page. I think it's the last one. It's called the summary, and that will tell you, no, it's not the last page. I put the quadratic formula in there for next class. But the summary page at the very end, I think it's slide 12, walks you through step by step on what you need to do. You might not understand each of those steps right now, but that is the page that you need to probably focus the most on. That, and also guided examples so you can see where everything's happening. So completing the square. Again, this is going to work every time. It doesn't matter what your quadratic looks like, it will work. It might be ugly numbers to deal with, but it will still work. So let's look at the rationale behind it. And I'm going to do that through this example right here. I have this quadratic here. It does not have a c term to make things a little easier for us, but even if it had a c term, you'd probably deal with it the same, very similarly. So here we have x squared minus 4x equals 5. And we want to find out what x equals, because again, we're going to solve the quadratic. We're going to find out what x equals. X could be one answer, x could be multiple answers. One answer, two answers, or it could have no real solution. In that case, you'll get imaginary numbers. However, this will pick up on the imaginary numbers. You'll actually be able to solve for the imaginary number this way too. And in fact, this method is also going to lead into why the quadratic formula works as well. But just to start off, we need to remind us of our special cases when it comes to solving squares. So these are the perfect square cases. And these were from last chapter. You used them a few times and you kind of just like noticed this section here, and you could jump right and be like, oh, I know this is going to be a perfect square. So here we have our first term is squared, so we have a squared here. And our last term, our c term, is squared, and that's going to be equal to b term. A times b times 2 will be your b term, kind of your middle term here. So you really don't have a c term because it's played off of these ones. But if it's in this form here, if it looks like this, you can factor it to this right away. You know this is going to be the factored version of it. So our goal here is to make this look like this. That's all there is to it. Might be a little weird. I could rewrite this as a squared minus 4a equals 5. So it looks a little more closer to this, but a could be x as well. So just looking at it, I'm trying to get this side to look like this. Well, how do I do that? So just looking at it, I'm going to rewrite it again, only I'm going to leave space for my last term. I have a squared minus 4a, and then I'm going to leave a space here because I know I need to put some number here for that b squared term. Has to equal 5. And if this was a perfect square, that's the key to this, is that you're going to want to make this a perfect square. So what do I need to attach onto here to make this a perfect square? Well, a squared is already like that, so I don't have to do anything there. Here I have a negative 4 times a. So you know that negative 4, according to this right here, right, this term here has to be 2 times a times b. We already have the a there, so it has to be 2 times b. So negative 4, in this case, is coming off to the side. Negative 4 has to equal 2 times b. In that case, what we're going to do to solve that is we are going to divide both of them by 2 and solve for b there. I can get what b equals if negative, right? So I'm going to divide that by 2, and I'm going to divide that by 2. And I know that b here has to equal negative 4 divided by 2. And negative 4 divided by 2 is going to give me negative 2. So I know b here has to equal negative 2 if this was a perfect square. And therefore, b squared over here has to be plus 4, because that's negative 2 squared. So I know I have to add 4 to this side. And once I do, this here, this phrase here is a perfect square, and I can factor it very easily like this. However, I can't just go and add 4 to one side like we've been doing all year. You can't just sit there and add 4 to this. So I'm going to have to add 4 to this side as well. So I'm going to go ahead and rewrite this yet again, only with it as a perfect square. So I have a squared minus 4a plus 4 equals, and then over here 5 plus 4 gives me 9, equals 9. So I know this is a perfect square now. So I can begin to rewrite this as this. So we know right away that we can do that. You'll note that it's actually this example down here because we have the negative sign here. So you're going to rewrite it like this, but I mean they're kind of the same thing. So what we're going to do is we're going to rewrite them, and it's going to be factored as a minus, and then we take the square root of this, right? The square root of that was the 2 squared, and that's going to be equal to 9. So once we get this part here, we can then go ahead, take the square root of both sides, take the square root of this side, and I can take the square root of this side, and this is going to equal a minus 2 equals plus or minus 3. Because again, the square root of 9, you get the plus version and the negative version. So it's plus or minus 3. If you're more comfortable, you can split that up and be a minus 2 equals negative 3 over here, and we'll just have the positive 3 over here. And you can solve for a, right? I can add 2 to this side, add 2 to this side, and I get a equals, that's a plus, not a 12. A equals 6. And over here I can add 2 to this side and add 2 to this side, and I get a equals negative 1. So there you go, those are your answers. However, again, just these were x's to begin with, so I guess I should write these as x equals those. I just changed them to a so you can see how it fits our format here. And I was able to solve. The trickiest part is figuring out what you add to it to get your perfect square on one side. And that you'll actually note is what we did over here, and that comes down to the fact that we can look at this right here. Right, that's going to cancel. So what we have is we have our b term, actually, let's not look at that. Let's go back to how we found that. I'll do that again. So we have this negative 4a, so we know that negative 4 times a, which we have the a here, we want that a to be in our term, so we're not going to do it, has to equal 2 times b. 2 times b. Is this going to help me out? Then you'll note that you divide each by 2 to solve for b. But yeah, divide by 2 and divide by 2. And then what you're going to do is you're actually going to square it all. So then you square it. However, I didn't want to do this exactly. I don't know why this isn't working out for me. I'll just give you what it's supposed to be. What you need to know. You need to know that this term here, how I got that number there, I did by taking my b term, which in this case was the -4, dividing it by 2, right, because the other side had -4 there, the b term, dividing it by 2, and then, because this has to be squared, right, because over here it has to be equal to b squared, this equals just the -4 in that case. You got to square that. So this here is how you're going to find that term every time. You're just going to take your b term, divide it by 2, and then square it. We can do another example here. Actually, let's do another easy one before I do a hard one. Just to walk you through everything again. I guess I deleted some of that. So coming off to the side, I'm going to rewrite this, and I'm going to remember that I want to take b, I want to divide it by 2, and I want to square it to get that term that I add to both sides. So looking at a problem, I'm actually just going to pick the first one out of your book here. B squared plus 3b, actually I'm changing it a bit, equals 4. I'm going to do it that way. I don't even know if that's how your book tells you to do it. I forget what notes I wrote for this. Okay, yeah, it wants you to rewrite. Okay, so your book is going to give it to you like this. I'll give it to you like your book. This is number 1 on your homework, which I think is number 7. For equals 0. It gives it to you in standard form. And standard form is all well and good. However, I don't like standard form for this because it makes things a little harder to do. You can still do this in standard form. It's just there's some more math to it that you probably don't want to get into, and it's just easier to get it out of standard form. So the first thing you want to do is I want to move my c term out. I want to take this -4 and move it to the other side. I don't care if these equal 0 today. So what I'm going to do is I'm going to add 4 to both sides and just move that c term out of there. That way it clears up that spot. So whatever this is going to go into that. I don't have to take this, solve it out, and then subtract 4 from it to put in there and combine it with the -4 here to do it. You can if you want to, but I'm just going to move it out so I don't have to deal with that. And equals 4 over here. So I just added 4 to both sides. And I left space here so I could figure out what number goes here. And that number is going to be solved by using this little equation here. So my b term here is 3. The coefficient to that is 3. So I'm going to plug in 3 here. So I'm going to do 3 halves, and then I'm going to square it. However, I'm going to leave it as a fraction because it might be easier to work with for me. I mean, it might not be for you. I'm just trying to think ahead. I'm going to leave mine as a fraction. So I'm going to go ahead and plug into this, and it's going to be 3 over 2 squared. So I know this is I'm going to add 3 halves, whatever 3 halves squared is, and 3 halves squared is 3 squared gives me 9, 2 squared gives me 4 is 9/4. So I'm going to add 9/4 to this side. And again, I'm going to leave it as a fraction just because it's probably going to be easier for me in the long run. And over here, because I did it to this side, I have to do it to this side too. So I'm just adding, not necessarily a random number, but I'm adding a number to this side to make it fit this pattern over here. But if I do that, I have to remember to do it to this side as well, plus 9/4 over here. With that, I can simplify this, finding common denominators of 4. That could be And then what do I do to, remember that's over 1. 1 times 4 gives me 4, so this would be 16. So this would equal 16 plus 9 is 25 fourths. And I'm gonna leave it as 25 fourths because I can take square roots of fractions by taking the square root of the numerator and square root of the denominator. Taking the square root of a decimal might be a little more tricky for you. So I am going to leave it as that. And again, right away you can see eventually I'm going to be taking the square root of this thing, and the square root of 25 is easy to figure out, and the square root of 4 is pretty easy to figure out. So that's looking nice over there. Over here, I'm going to simplify using our perfect squares. You'll note that it's this case this time because we have that plus there. So I'm going to be putting a plus sign in there. And I take the square root of b squared, which is b. And I take the square root of this, which is actually going to be this 3/2. So that's going to be plus 3/2, and that gets squared as well. And that's going to equal 25 fourths due to all of this combining. Better looking for there. Then I'm going to take the square root of both sides. Right? I'm just going to solve for b here. I'm going to take the square root of this side, and I'm going to take the square root of this side. Taking the square root over here just leaves me with b plus 3/2. And over here, this is going to be the plus or minus, because again, I get both. And then the square root of 25 is 5, square root of 4 is 2, 5/2. And that works out nicely too because my denominators are both the same already. I don't have to find common denominators when I do all this, but solve for both of them. Again, if you want to write them separately and not use the plus minus thing, might be easier. Let's do the minus 1 here, and then plus 3/2 equals the positive 5/2. Over here, we're going to subtract 3/2, subtract 3/2, and we get b equals 5 plus 3 is negative 8/2, which can be reduced. 8 divided by 2 gives me negative 4. And over here, we can solve by subtracting 3/2 from this side and subtracting 3/2 from this side. B equals 5 minus 3 in this case is 2/2, which equals 1. So your answers are b equals negative 4 and b equals 1. I'm on my face, aren't I? Yeah, sorry. Move my work over a bit so you can actually see it. That would be helpful. So over here, you get your answers of b minus 4 and b plus 1, or positive 1. B equals negative 4 and b equals positive 1. So again, it is just by completing the square, and it gets that name actually from your area definition of multiplication. And I don't have algebra tiles to show you that, but it does get into that. So that was number 7, just to give you an idea. Let's get a more complicated problem, because sometimes they're not nice looking like that. And this one's going to be very ugly, but the reason I'm going to show you this one is because this will work for it. You will get an answer for it. It's just going to be a very ugly answer. So keep that in mind. But let's do one that's fairly complicated. 10x squared minus 30x minus 8 equals 0. Now, just looking at this right away, you probably don't want to be like, Mr. Grant, don't tell me to factor that, because it's not going to be fun to factor. But looking at it right away, one thing that you should be able to notice at this point is that you can divide everything by 2. Everything here is divisible by 2 to make things easier. And I'm going to go ahead and do that, even though it's probably not necessarily what I want to do. I can do it. It's going to add an extra step for me probably, and you'll see in a minute. But I am going to go through and divide by 2, because each one of these is divisible by 2. So I'm going to divide this term by 2. I'm going to divide this term by 2. I'm going to divide this term by 2. And don't forget to divide this term by 2 as well. So each term gets divided by 2. In that case, 10 divided by 2 gives me 5x squared. Negative 30 divided by 2 gives me negative 15x. Negative 8 divided by 2 gives me negative 4. And 0 divided by 2 gives me 0. Now, if I were to ask you to factor this, you'd be pretty hard to do. I mean, you're going to slide and divide. This is going to become a 20. You need factors of negative 20 that are going to add up to negative 15. And you probably don't want to sit there and go through all the different decimal options that you have, because they're not going to be straight up obvious. So you probably don't want to factor this. But this is also not written in this form. So again, I got to get it to one of these forms. We have the minus one, so we're going to look at this form here because it has a minus. But we want to get it to one of these forms. Let's get rid of this little bracket. So what I'm going to do is, first off, get rid of this 5. And to get rid of that 5, what I'm going to do is I'm just going to divide through by 5. And you're probably, well, I don't know if you are, but at least one of you is probably thinking, well, if you're just dividing through by 5 here, why didn't you just up here divide through by 10? And you could have. It's just that when you probably didn't, once you got to this step, you're probably, well, I don't want to divide through by 5 because that makes this a fraction, and you probably wanted to stay away from the fraction. But we do want to divide through by 5, so, or you could have just divided by 10 through the whole thing. That's why this step really wasn't necessary. But I am going to divide through by 5 here, and that's going to give me x squared minus 3x. And this is a fraction. I'm just going to leave it as a fraction. Minus 4/5 equals 0. So I mean, I really didn't divide that. I just kind of left it how it was, and that's fine because I can work with fractions. Again, they're not the prettiest to work with, but it at least gets you an idea of what's going on. And then it kind of goes back to what this kind of looks like the other ones that we did. You have no coefficient in front of here. You're subtracting your b term here. But you have your c term on this side, and we want to move it over. Again, you could deal with it on this side here, and just when you solve this, tack it on. But to me, it's a lot easier to just move it on the other side first and deal with it later on when you're doing your actual algebra. Well, this is all algebra. When you're doing your actual solving for x. So what I'm going to do is I'm going to add 4/5 to both sides just to move it over. And then I'm going to rewrite it x squared minus 3x. And in this case, I'm going to leave that spot blank because I got to complete my square and put that term in there. And 0 plus 4/5 gives you 4/5. So I just move the negative 4/5 over. And then I got to complete the square. So I got to use this little thing here, or just kind of, you know, reason through it. You have your x term already, if this was the x, a's being the x here. So 2b equals your negative 3 here. So you know that 2b equals negative 3. But if you plug into this, it'll solve it. It's the same thing. It's just rewrote. And then this one squares it because we need to square it for this term. But go ahead and plug it in, so you get negative 3 over 2 squared. Negative 3 over 2 squared is going to be, let's see, negative 3 squared gives you 9, and 2 squared gives you 4. I think we just had that one. And this is going to be positive now because the negative gets carried with it. So just watch your signs. And it gets there. Now we need to solve, right? And you could sit there and you can, it is in this form now. Sorry, we're using this one. It is in this form, so we are going to go ahead and rewrite it as a minus, oh, I'm sorry, not a, we have x here. X minus 9/4 I'm sorry, we want the square root of that. We want to take the square root of that. We take the square root of this, and we take the square root of that. So the square root of 9 is 3, and the square root of 4 is 2. And then we square it there, and that's going to equal 4/5. When you get to this step, again, you're going to take the square root of both sides, and that's going to start looking pretty ugly. So we're going to take the square root of this side, and we're going to take the square root of that side, so you get x minus 3/2 equals the plus or minus square root of 4/5, which you probably don't want to solve, just because it's, again, they're not, 5 isn't a perfect square, so that's going to be rough. If you wanted to do the square root of 4, you probably could reduce that part down, but then you still have to take the square root of 5 at the end. So it's up to you on how far you want to reduce that side right now. But you are going to use a calculator for this, and I'll pull my calculator up and show you how to plug it all in. So, and then we're going to, let's see, how close with my face? I got room. So over here, we'll put the negative version here, and we'll put the positive version here. So we have x minus 3/2 equals the square root of 4/5. Okay, and then you're going to just solve like you normally do. So we're going to add 3/2 here, and you're going to be left with x, but we're going to add 3/2 to this one as well. So we have negative square root of 4/5 plus 3/2 is going to equal x, and then you got to put that in your calculator and solve it out the best you can. And we'll probably end up rounding because this is going to be irrational with that square root being all wonky. Over here, same deal, plus 3/2 plus 3/2. So here you get x equals square root of 4/5 plus 3/2. I'm not quite in my face yet. And to solve that, just bring up a calculator and type it in the calculator. Just be careful on how you type things into the calculators. So we have 1 negative, and then the square root is your second x squared. And then it's going to give you parentheses, so I want the 4 divided by 5 in there. And then I want to add the fraction 3/2. Again, if you want to put like 1.5, that's fine too, but 3/2. So our first answer is 0.60557, that. So let's just say, hey, x equals, what was that? We'll say 0.606. 0.606. And we'll also calculate the other one. And if you don't know how to use your calculator, you're just going to recall that second entry, but we don't want the negative version of that, so we're going to delete that. And you get x equals 2.394. Again, they're ugly numbers, but that just shows you that you can solve these using the perfect square for it. You're not going to get too complicated today. But if you look at the summary on how to do these, it tells you step by step on what you do for them. It says this was slide 12 for everyone who's not looking at it. So step 1 is divide through by the a value, right? And that's if a does not equal 1, divide everything by a. Step 2 was get it equal to 0, I think. Yeah. Get the c term, get the constant to the other side. So you just have these two terms on one side. Step 3 is actually completing the square, which is using that b over 2 squared to complete the square. Step 4 is, how did I word this? Write the left side as a square and simplify the right side. Okay, so then actually factor as a perfect square, because now it's a perfect square, and simplify the other side, because you probably have something to add to it. And then number 5 is just solving it like we've been doing. Solve with the algebra. So with that, does anyone need me to do another example or something, or do you think you can handle your work, which is page 538, 7 through 21? And again, this, you're going to have 2 days to do this, because I don't know if I'm going to live stream tomorrow due to other things that I got going on. Not too complicated if you understand how all of it's working, but it is kind of a unique way to solve things that you probably haven't seen before. Kind of creative, but it will work for every single case. Well, if you have no questions, then I'll let you go, so you can work on that. Is the last one you did with the 10, you just divide in the beginning? Yeah, okay, so whenever you have, I don't think I gave you any like that today. Maybe I did. Yeah, so if I'm looking at like 16, you have 2c squared minus 7c equals -5. Whatever this term is, just divide everything by that term. If this term is 1, then it's not going to change anything, so you don't have to do that. The one I gave you was 10x squared minus 30x minus 8. I could have just divided each of these by 10 to begin with. Equals 0. Right, that would still have given me my x squared minus, and then this would give me my -3x. This here would give me -8/10, which reduced down to, what is that? Was it 4/5? Yeah, that -4/5 equals 0. So you get the same step. It's just, you probably, based on what I taught you already, you probably should have noticed that, hey, you can factor out a 2 from that. You can divide everything by 2 here because these are all even numbers. So the 2 was like an obvious thing to do, whether if you knew how to do this or not. But then you would have done it by 5, and 2 times 5 gives you 10. So it would have been the same thing as just doing it by 10. But here you can divide everything by 2. Yeah, that's going to be an ugly number, but you'll work with it. Any other questions? And again, also, if you're wondering, once you divide everything by 2 here, you don't have to remultiply by 2 because you're doing it to both sides. I mean, this is the same thing as, say, divide that by 2, divide this by 2. So no, once you divide it by 2, it's gone. It's done. You don't need to bring it back because you did it to both sides. If you only did it to one side, then yeah, you'd have to bring it back. But here, the statement stays true if you do the same thing to both sides. It's a good question. See, if there's nothing else, feel free to email me. Pay attention to the Google Classroom. I don't know how my schedule is actually working depending on what I hear today. I may or may not be live streaming. As of right now, it's looking like I'm not, just because I need to, that's my opportunity to go into school and get stuff from my classroom that I haven't seen in a month. So I won't be home to live stream. If you have further questions, shoot me an email. If not, I'm going to end it. Have a good day. Oh, what page is to work on? Right there. I think that's what it is. Is it? Oh, no, that's not the right page. I did the wrong page today. I solved other problems that way. I'm sorry, don't do that. Your problems were 7 through 18. It's 544, 7 through 18. Wow, I was looking at the wrong assignment. I can do 7 for you. I did the first one anyway. Right. R squared plus 8r equals 48. Again, you're going to do half of b, which is 4. 4 squared is 16. So this is r squared plus 8r plus 16 equals 48 plus 16. In that case, you're going to get r squared plus 8r plus 16 equals, and then 48 plus 16 gives us, I'll do it after this. 48 plus 16 gives you 64. Then again, take the, in this case we're using the first one because it's a plus. So factor it, r plus 4 squared equals 64. Take the square root of that side, take the square root of that side, you get r plus 4 equals plus or minus 8. Add 4, you get r equals 8 plus 4 is 12. Subtract or add 4 to the negative side, you get r equals negative 4. So those are your answers. But yeah, I can do 16 as well if you want. Yeah, I didn't give you any of that divide 3 today. I was looking at the wrong assignment. I mean, they were the same kind of problems. The book was just asking you to do this by factoring. There's that. I can do another one here. And if you want 16, I can do 16. W squared plus 3w minus 5 equals 0. In this case, you have that c term, so move that over. So you get w squared plus 3w equals 5. Again, add 5 to both sides, move it over. So I just moved it over. That way I can figure out what I need to add to both sides using this little template. So 3 divided by 2 squared is w squared equals 3w, and then it's 3 divided by 2 squared. So 3 squared is 9, and 2 squared is 4, equals 5 plus 9/4. Again, you can use your calculator to solve that if you want, or just get common denominators, which isn't too hard either. So w squared plus 3w plus 9/4 equals, so that's 5 over 1 times 4 is 20/4 plus 9/4, which equals 29/4. So in this case we have w, and again this is a plus, so we're using the plus sign, plus 3/2 squared equals 29/4. Take the square root of both sides, you get w plus 3/2 equals plus or minus the square root of 29/4. Again, if you prefer actually solving the square root of 4, you could write this as w plus 3/2 equals plus or minus square root of 29 over 2. Those are the same thing, because you can just distribute the square root to both of them. But it might just as well do the 29/4. In that case, you're going to subtract 3/2 from both of them, and subtract 3/2 from that one. So this here is technically your answer. I just solve it out. And again, you probably want to use the calculator for it. So you get square root of 29 by 4. That minus 3 divided by 2 gives you 1.19. W is also going to equal the negative version of that. So square root of 29/4. We want the negative version of that, so it's multiplied by -1. And minus 3/2 gives you negative 4.19. So those are your ugly answers. If you have any further questions, shoot me an email. But don't be afraid of ugly numbers today, because this is designed to work in every case. So if they were nice numbers, then you probably would have used either factoring or square rooting or whatever to solve it. But this will work every time. With that, I'm going to end it. Again, more questions, email me, and I'll try to get back to you.